The first concept of chapter 2 talks about the significance of chemistry in biology course. The example that they have given to make us understand is the um, Devil's Garden story in Amazon forest, where ants use formic acid to remove the other species because they like only Doroya trees as their habitat or as their houses. But people there used to think that there is a ghost or the forest is possessed by some kind of unknown power or a devil, and that plays a role in um, cultivating only one kind of species, that is Doroya trees in Amazon forest. Whereas researchers went in there and did the research, and they found that it is not true. The misconception or belief that the Doroya trees are selected by some kind of ghost or devil. These are Doroya trees. The experiment here is the scientists, when they figured out that the ants must be the actual the key players in removing other species, uh, they designed their experiment to check this hypothesis, to test this hypothesis. They planted Cedrella species in this region of the some with insect barrier and some without insect barrier. They came after some days and checked, and they saw that unprotected ones died, whereas the protected ones did not die, and they survived just like a Doroya species. So they saw that their hypothesis was acceptable, that the ants are injecting formic acid into the leaf tissue, and that chemical causes death, and in turn the plant dies eventually. So this is how single species is maintained by Devil's Garden in Amazon forest, and it is not any kind of unknown power, superpower, unknown power. So coming to the real concept, what is matter? Anything other than vacuum is made of matter. Living organisms are also made of matter. What is matter? Matter is anything that takes up space and has mass. Matter is made of elements. What is element? Element is any substance, example, oxygen, carbon, helium, gold, silver. These are all different elements. Compound is a substance which consists of two or more different elements. Remember, when hydrogen and hydrogen together form H2, hydrogen gas molecule, then it is not qualified to be called a compound, because it is made of two same elements. So H2 is a molecule, not a compound, whereas H2O, it is a group of atoms made of two different elements, hydrogen and oxygen. That is why it is called a compound. There are total of there are total of 92 elements that occur naturally, and (118) elements with artificially synthesized elements added to the list. Out of these 92 naturally occurring elements, only 25 of them are considered essential elements. So these are the essential elements. Let me quickly check if the recording is still on. Still on. Out of these 25 essential elements, the top 4 essential elements are carbon, hydrogen, oxygen, and nitrogen. Together we can make a mnemonic or just a word to remember, CHON. Remember, the top 4 essential elements are CHON. What are essential elements? Essential elements are those elements which make living organisms. Living organisms need these elements in order to live, function. Without these elements, we won't be able to survive and function. Other elements are all this list. You may have to remember some of these trace elements. Remember, trace elements are also essential elements, and they are called trace elements because they are required in small quantities. You may answer this question now, and this is possibly one of the questions on your test one. What is atom, subatomic particles, and atomic structure? That is what we are going to learn in this concept 2.2. Atom is the smallest unit of matter. Any element is made of atoms. Carbon is also made of atoms. Hydrogen is also made of atoms. Phosphorus is also made of atoms. An atom is the smallest unit of matter, and it is composed of 3 subatomic particles. I want you to remember this. It is 3 subatomic particles. 3. And they are neutrons, protons, electrons. Neutrons do not have any charge. They are neutral. N for neutrons, N for neutral. Protons are positively charged subatomic particles. P for protons, P for positive. Electrons are negatively charged subatomic particles. There are more than 3 subatomic particles making an atom, but we are going to remember only 3, and we will learn how they are placed in an atom when we learn the atomic structure. In order to understand how to draw an atomic structure, we have to learn some more concepts. But before you move to the next concept, I want you to memorize these 3 subatomic particles and their charges. On top of that, you also need to know that neutrons and protons, they are collectively they're collectively placed in the center of the atom, and it is called nucleus. So neutrons and protons in an atom are collected inside the nucleus of an atom. Yes, atom has a central part called nucleus. And electrons are outside the nucleus. Some more information about these subatomic particles. Each neutron and each proton has mass, and the unit of measurement for mass is Dalton. 1 neutron is 1 Dalton in mass, and 1 proton is 1 Dalton in mass. What is Dalton? Just like milligrams, we use milligrams, grams. These are the measurement units. Like that, Dalton is also a measurement unit, but for very small particles. Remember, electrons are very small in size, so it is negligible. Textbook says it is 1/2000 of 1 Dalton. Atom's mass comes from its nucleus because neutrons and protons have at least mass which is considerable and which can be weighed in Daltons. Remember, nucleus contains protons, positively charged particles, and neutrons do not contribute any charge. So nucleus, which is core of an atom, is positively charged, whereas electrons are There are some rules for placing the electrons in an atom. The rules for filling the electrons in an atom are: the first shell, which is this ring close to nucleus, is called first shell, can hold maximum of 2 electrons only, whereas the second shell can hold maximum of 8 electrons. That is total of 8 electrons. Third shell can hold maximum of 8 or 18. Remember, this is 8 or 18, though I wrote only 18 here. So this is something that you need to remember later on for filling the electrons. Electrons are rotating around the nucleus in these rings, and these rings are called energy levels or electron shells. So you can see this is a periodic table, and in this periodic table they have given the atomic structures and symbols of the elements and their names and some number and their atomic structures. You have to learn how to draw these atomic structures for this class. Couple of terms that you need to know in order to understand the concepts to draw the structure of an atom. Let's take an example of sodium, Na1123. Sodium contains electrons, protons, and neutrons. And in a periodic table, you can see Na, sodium, has 2 numbers around it. You can find the periodic table charts in textbooks and in classrooms while you're taking the test on the wall. And if you're taking the higher level tests such as MCAT, then you may have to memorize most of the elements, atomic number and mass number. So what is atomic number and what is mass number? In a periodic table, the elements are listed like this and with the symbol, and they give 2 numbers. The small number is called atomic number and the large number is called mass number. Small number, atomic number, is equal to number of protons. Small number, which is atomic number, is always equal to number of electrons in a neutral atom as well. Mass number is equal to sum of protons and neutrons. So in this case, sodium's atomic number 11, that means there are 11 electrons and 11 protons. Mass number is 23, that means number of protons plus number of neutrons is 23 in sodium. What is atomic mass? Atomic mass is atom's total mass. Remember, total mass of an atom comes from number of neutrons and protons. Atomic mass has more specific definition, which is coming up. So take few minutes, pause the video and try to answer this question. Now, the answer for this question should be C. Can you calculate number of neutrons of every element if atomic number and mass number are given? Yes, it's easy. Formula for calculating the number of neutrons is mass number minus atomic number. 23 minus 11 in case of sodium, which will give you number of neutrons for sodium would be 12. Next terminology that you need to know is isotope. What is isotope or isotopes? Isotopes are all atoms of an element that have same number of protons and same number of electrons but different number of neutrons. For example, C12, C13, and C14. So you can see that this is carbon, but its mass number is different, and all of them have atomic number 6. So these are all isotopes of carbon because they have different number of neutrons. Now apply this formula to calculate the number of neutrons so that you can understand. I want you to remember this example forever. Not only carbon, many other elements have isotopes like this. So not all isotopes are radioactive. Radioactive isotopes are those atomic forms of an element which give off particles and energy, and they are harmful to us. So we do not want to be in close contact with radioactive isotopes. Coming to the definition of atomic mass is average of mass numbers of isotopes of an element. Remember, sodium atomic mass is 22.9898, whereas its mass number is 23 for Na1123 because its isotopes average mass numbers are averaged. Disorders such as cancer, that is presence of tumors, or metabolic process such as how we are processing the carbohydrates or sugars. In case of detecting diabetes. This is a very good question to understand and identify if you really know and are able to apply the definition of isotopes. As you can see that both atom 1 and atom 2 are hydrogens. Hydrogen has atomic number 1, whereas one isotope has a mass number of 1, another isotope has mass number of 3. So these are two different atomic forms of same element, hydrogen. So these are not isomers or polymers, but they are isotopes. This is a very good example to show how scanning of tumor is using radioactive isotopes, and how tumors absorb the radioactive isotopes and they show up in scan. Coming to the energy levels or electron shells. Remember, these are the concentric paths of electrons. Electrons are going around the nucleus, just like solar system has sun and planets are rotating and revolving around them. Like that, atom also has a nucleus containing protons and neutrons, and electrons are going around in these energy levels. Energy levels are numbered 1, 2, 3 as we go away from the nucleus. First shell has lower energy compared to the second shell, and second shell has lower energy compared to the third shell. This is a periodic table. Let's learn how to draw the atomic structures like this and understand why atoms form groups, and they're called molecules or compounds. As you can see, hydrogen's atomic number is 1. That means it has photon, has 1 proton and 0 neutrons, because H11, remember, we're not talking about its radioactive isotope. Whereas 1 electron, so in its first orbit we are putting only 1 dot. Look at this, helium. Helium atomic number is 2, mass number is 4. So it has 2 protons, it has 2 protons and 2 neutrons, whereas 2 electrons are in its first orbit. Yeah, so this is how atomic structure is drawn. Make sure you practice atomic structures for carbon, nitrogen, and oxygen. You have to memorize on carbon, nitrogen, oxygen, and hydrogen's atomic number and mass number from your periodic table. It's important. So what is valence shell? Valence shell is the outermost shell. In case of hydrogen, it has only one shell, and that is the outermost shell. So first shell is the valence shell in case of hydrogen and helium. And coming to all the elements in the second row. So carbon, nitrogen, oxygen, their valence shell is 2 and their valence electrons differ. So how many ever electrons are there in valence shell? They are called valence electrons. Valence electrons in carbon are only 4. Remember, the total number of electrons are 6, but then valence electrons are 4. So carbon is not happy atom. Carbon atom is not happy because its outermost shell, that is valence shell, is not full. Remember, second shell likes to have maximum of 8, but it has only 4. So carbon is always looking for 4 more electrons, either from other carbons or any other elements such as hydrogen, nitrogen, oxygen, and many others. Whoever is willing to share its electrons or give away electrons, these elements which are lacking the electrons in its valence shell, if they're not full, they're happy to accept those electrons. You can look at the last row in this periodic table. You can see that their valence shells are complete. So these elements, helium, neon, argon, they are not going to ask for more electrons because they're happy single. Whereas other elements, they are looking for other atoms to share their electrons with them. So this is valence electrons, valence shell. So why do atoms form chemical bonds with similar elements or same elements, atoms, or other elements, atoms? It's because their valence shell has insufficient electrons compared to the maximum number. That is the reason why they want to form groups. Coming to the orbital. Orbital is a part of orbit where electrons spend maximum time. Orbitals have different shape. Some are spherical, some are dumbbell in shape. Each orbital can take maximum of 2 electrons. We're not going to go deeper into orbitals for this chapter. What is a chemical bond? Bond means attraction. Bond formed between chemical atoms is chemical bond. Why do atoms form chemical bonds? As I said earlier, their valence shell is not full, so they are looking for other atoms to contribute electrons to them for filling up their valence shell. That's the reason why atoms exist in groups, and this formation of groups is due to the sharing or transfer of electrons. So let's see different chemical bonds. There are 4 types of chemical bonds: covalent bond, ionic bond, hydrogen bond, and van der Waals interactions. I'm going to talk about these different types of bonds and why atoms form these different types of bonds in my next video.